Welcome. In this video, we're going to go over how to evaluate vector valued functions for given points and then find their domain. And then really quickly on my own screen, yours is correct, but mine, I lost the top of this square root. So there it is. So first thing we're going to do is we're going to evaluate this vector valued function when t equals 0. Okay, so r evaluated at 0. We just go ahead and replace as you would in, an algebra class. Every t with a 0. So this is cosine of 0, comma, the natural log of 4 minus 0, comma, the square root of 0 plus 1. So this vector valued function r evaluated at 0 becomes 1, comma, the natural log of 4, comma, 1. All right, next let's find its domain. Okay, so for that, I'm going to make a little table here. So I'm going to go ahead and write function and domain. So our first function, x of t, the one that provides us with the x coordinate of this vector valued function, well, that's cosine of t. And its domain is all real numbers, so that's negative infinity to infinity. You can also just use this symbol, this big double R, to represent all real numbers. Okay, so now let's look at the y-coordinate. Y of t gives us the y-coordinate, and that's the natural log of 4 minus t. So I'm going to do a little work aside here for this one. For the domain of the natural log of 4 minus t, what we need is the argument, so this 4 minus t in here to be larger than 0. So 4 minus t larger than 0. That occurs when t is less than 4. Okay, so I'll write that down right here. Now finally, let's go ahead and look at the domain of the function, which provides our z-coordinate, which is the square root of t plus 1. And I'll go ahead and do a little bit of a side work here as well. So for a square root or any even root, we need whatever's inside of it to be greater than or equal to 0. So t plus 1 greater than or equal to 0. This occurs when t is larger than or equal to negative 1. So now what we need to do is reconcile all three of these domains. A number line can really help us with this, so don't underestimate using tools you learned in classes like algebra or pre-algebra. These are really useful tools, so keep using them. So let's start with that number line here. And this is the real number line. I'm going to place a 0 here. I'll stop at 5 here and negative 4 on the left. The domain of cosine of t, which gives our x-coordinate, is the real numbered line, so it's all of this. The domain of y of t, which gives our y-coordinate, is t is less than 4. So here's 4, and we're going off in this direction. Finally, the domain of the function that gives our z-coordinate here is t is greater than or equal to negative 1. Now we want to take the most restrictive domain, so the one where all of these domains in essence overlap. And they all overlap here between negative 1 and positive 4. So we can take this domain to be all values of x, such that x is at least negative 1 all the way through positive 4. Okay, let's write this in a little more condensed manner. What I did here is I literally just translated this negative 1 here, and the bracket notation from algebra. So our domain is from negative 1 to 4. All right, so it looks like we did everything we needed to do. We evaluated our vector value function r when t equals 0, and we also found its domain. I hope you found this video helpful.